we wanted to use carbon nanotubes to fabricate a transistor. Carbon nanotube transistors are kind of the future. They're where electronics are trying to go, making things smaller. So that was what we did. We used carbon nanotubes, and we wanted to try and make and test a transistor, see if we could get transistor properties from the carbon nanotubes.
If you imagine graphene, the thing, what your pencil's made out of, rolled into a sheet. So it makes a tube, and it's 1,000 times more conductive than copper and several hundred times stronger than steel.
First, we got carbon nanotubes from UW-Madison. They supply us with the carbon nanotubes, and we had to go through the process of fabricating the transistor. So we had to, get a carbon nanotube transistor that we could use. So we went through the fabrication process, and then we also imaged them using some equipment that we have at Platteville, a scanning electron microscope and an atomic force microscope. And then Sarah and Lindsay created a program in LabVIEW.
We made a program in LabVIEW to basically talk to the generators in order to sweep voltage from the drain source and the gate source and measure current and see if our transistors had transistor-like properties. So we used the data gathered from the LabVIEW program, and we would create sweeps of these graphs, and we would basically compare them to other transistors as well as like carbon nanotube transistors in particular. We actually did achieve transistor-like properties with our carbon nanotubes. The main reason we were looking for the comparison of our spun transistors compared to the UW-Madison's aligned. The spun transistors create like a mesh, like a grid of the carbon nanotubes create a mesh of these nanotubes, correct. And we found that they do indeed achieve transistor-like properties.
So one of the things that we're looking to test is gas and sense for gas. And so what Lindsay is doing this semester is she's looking at, since the mesh, we're trying to see if it holds more gas inside of that versus the aligned nanotubes. And so on our data, once we zapped it with the UV light, we noticed a difference in the voltage across the transistors. And so and after the UV went away, it returned back to the normal properties that we had before. And so that is giving us an accurate measurement of the gas is present or the gas is not present. And so it could help with emissions testings or various sensors.
We're interested in doing research for a professor, and a lot of us were interested in more of the nano, the smaller scale science. So we went to our professor asking if he had research available, because he had done a sabbatical looking at stuff very similar to this. So we asked if he had research, and he had research that we could do. And so we were actually, me and Charles and I were one research team, and then Lindsay and Sarah were a separate research team. And so after we had gotten to a certain point, we came together and finished our research. So we all had interest in this field.
I'm very interested in material science, and being able to study the effect of the carbon nanotubes and such on a smaller scale really made the nanomaterial science come alive, I guess, with this research. So I was able to practically apply what I'm learning in school to something that could be potentially used for everyday applications.
I'm more interested in the biomedical field, and I'm interested in the biomedical devices. And so a lot of the biomedical devices are going nanoscale now, and so that's why I was kind of interested in more of the nanoscale side of things, and that's kind of what brought me into the carbon nanotubes.